Good evening, everyone, and thank you so much for coming to this gathering. Hope you all are having an awesome time. Also, thank you to Patrick for helping put this together, and for all of our speakers who will be presenting this evening. We have a number of lightning talks lined up. People will be speaking for roughly 5 minutes. Anyone that goes over 5 minutes gets thrown in the pool. And we're going to jump right in any minute now.
All right, thanks, Rich. Those of you that don't know him from the Ceph community, that's Rich Bowen. He's the upstream guy for RDO. And those of you that don't know me and have just been arriving, I'm Patrick McGarry. I'm the upstream guy for Ceph. Welcome to an evening of Ceph and RDO, where we have consumables for your face on the table at the bar and consumables for your brain here up front. So if you are merely interested in the consumables for your face, please enjoy them. And go ahead and go outside for conversations and whatnot. In here, we will have the conversations and presentations for your brain. So those that want to watch the speakers, please stay in here. We have space for everyone. We are going to do, as Rich mentioned, a series of 5-minute lightning talks. And hopefully we'll have plenty of time afterwards for you to hunt down the speakers and grill them further. So we're going to go ahead and jump right into the content. We'll get rolling so that you'll have plenty of time to beat them up in a dark corner to find out more. So the first speakers we invite up to the stage here, we have our friends from Intel. John, Jack, you are the first to enter the ceremonial bus, right underneath. All right, there we go. All right. Welcome these guys. The Intel folks have been long part of the Ceph community, so it's been great to have them up here. Why don't you go ahead and use your own laptop, I think? We're going to record.
Yeah, I'm actually using my webcam here.
So you have VGA or HDMI? Which one? VGA, right here. Right on top.
Right here. 245.
Oh man. All right, some people have slides, so if you want to see them, make sure you can see the screen. Some don't have slides, and one random presentation tonight drawn from a hat will be forced to juggle. So hopefully that will be just as entertaining. So I will now turn it over to John from Intel.
Hi everyone, this is Jay from Intel. So I'm going to do some quick introduction on the Ceph complex array with Intel 3D NAND based on rooftop. So considering we only have 5 minutes, 5 to 10 minutes, I will skip to the important part. This is the first 3D NAND based reference architecture. We have a platform. Each node was configured with 4 P3530 3D NAND SSD. And we are using Ceph rooftop, the latest master release. So we have to do some tuning, which the tuning is including this pattern. So here is the performance overview. Let's take a look, quick look. So for the 4Q random write, for the 4Q random read, we were able to deliver like 1.2 million outputs with 1 minute latency. So the throughput is actually corrected by the NIC bandwidth. And for the 4Q random write, it's 270K. Which is pretty close to the P3520's spec throughput. And for the 64 sequential read and write, we are out of the NIC throughput limitation. So this is actually the scanning. We also do a scanning on all the 4 test cases. We could see that with rooftop today, and with one actual PCI drive as the WFG device and ROCDB, the performance is really awesome. So we already able to saturate all the hardware. So this is basically the tuning. We can see that the model tuning for ROCDB. So we know that we use ROCDB as a write analog device and a metadata device. So we did a lot of tuning. So the big thing is we need to configure the ROCDB for the compaction, and we will have to disable sometimes the EDU flag. So, but you know, the test is only lasts like for 30 minutes, 300 seconds. So the compaction will happen eventually. So the problem is we will probably need a new database for this part. Yeah.
but just quick, this is two technologies is moving forward. Intel Optane drive is based on 3D platform, and it's moving in the middle is CPU and hard data, so CPU, DRAM, and then you're going to fill the gaps using the Intel Optane drive, fill the gap between the DRAM and the current flash SSD. And the other side, we're moving to approaching to the hard drive, replacing the hard drive with 3D SSDs. I think I'm going to go to the last page. Yeah, that's the Ceph. No, not that. Okay, we can do this. So basically, this is Optane drive. This is RockDB. Without any tuning, the current per tap can get 3 times throughput with the 10 times latency reduced. And then going forward, we suggest the Ceph community replacing the current P3700 with the Optane drive as either journal or Mac data, RockDB, or whatever DB to store that in front to be performance fair. And then on the back end, we use a lot of low-cost, high-density 3D SSD, which give you performance plus battery.
Thank you. Our next speaker is Heiko Gemart, who is one of the guys that puts together RDO packages. He'll be speaking, he'll be giving us an update on the status of the RDO project. It's actually setting a time.
Yeah.
That's official.
Okay. Let's start. Okay, this. Let's go.
Okay. So I'll be speaking about RDO neutral status running the iPhone, but RDO died. So let's start about 10 hours. This is the time from QTA announcement from the time we got RDO neutral repository released. So during the last meetup, we were discussing about 2 hours. So we still have margin to go there, but still, we were the first binary distribution of OpenStack to be available. I'm not thanking Gang 2, that's cheating. So for this cycle, we've been working with Fabien Boucher about stable builds automation. So now you can submit builds through Garrett. So every time you want to have a new patch update, you submit an update to Garrett. You just have to change the version, and if it gets merged, it will be automatically built. And in consequence, we've been able to merge DeLorean and stable branches. So that means it's less confusing than it used to be. So another big thing that is coming asynchronously is our alternate architecture. So we're introducing 2 new architectures, which are ARM64 and PowerPC 64. So current status, ARM64 is already bootstrapped, and it's running, actually. So we're still waiting for Central Cards to set up the repository. As for PPC64 LE, Bootstrap is coming soon. We work on that. All the core services are running. except for telemetry that is pending an update of MongoDB 3.2, which is coming soon, but it's kind of bad chance. So I'd like to thank a few people for that. First, Martin USC from Red Hat, Jan Daniel from IBM, and all the people from CentOS, but Thomas Ove from CERN, who spent his evening helping me to set up ARM64 architecture. Thank him. And the CentOS core team for this report, and Peter Benson. So, upcoming. Since now we have automated both. We have one part that is not automated are the updates. So this is what is coming for this cycle. We're trying to extend the automation to have bigger branches. For now, it's only running on Newton, but I think during the open cycle, we'll be extending it to both data branches. And there's work in progress to migrate RDO to Cat 4 or Kappa. So that's work is spearheaded by Emily Mackey. We've worked to fix OpenStack models and testing that. And also my colleagues Javier and Alfredo working to fix FastStack. And we have some expectation about that. So this is pretty much it. We have been pretty much efficient about releasing RDO recently. There was no big bugs. So the day of the TA, we were pretty much ready. So if you have any questions, feel free to grab me. I'm the weird guy with the hat. And there are many other people from the RDO team, so feel free to ask us. And thank you for joining this tonight.
All right, thank you. Now, next up, we have Lars from Ceph, who's going to talk a little bit about the management stuff that they've been working on.
Yeah.
Where's the people at the back or
All right, well, Lars is getting set up. Just a reminder, if you have side conversations and aren't interested in listening to the presentations, feel free to enjoy all of the deck. You can go all the way around behind the pool. That's all open and available. So then the people in here are able to hear the content. So, Lars, you're up.
Thank you, Patrick. So, I'm not sure how many of you have ever tried managing Ceph, right? The current situation today is actually pretty depressing, or very differentiated if you want. So there's plenty of deployment options, many management tools, many monitoring tools, and I'm not going to list them all here. There's probably more than I don't know about. And the truth is, all of these are implemented on top of inferior interfaces, right? They all call out to the Ceph command line. They all call out liberators, because there's not really a good management front end for Ceph. And some of these have very bad guarantees. Liberators will actually block if the monitor is down, or just hang, unpredictably long, and they end up reparsing objects. Ceph calls, give them back JSON, and they end up reparsing that. So that's just terribly inefficient. And let's look at some of the needs that we have, right? So a common backend would be really cool, because if we have all those different front ends, it's really annoying if you have to have all that divergence, right? So it's a Susan guy talking at a Red Hat event, and we're converging on the storage, and we have a really hard time converging on the management part, right? So product manager believes that product differentiation is good, and engineers hate that. So we're trying to sneak in convergence without the product managers noticing. So we need a common backend for the Ceph cluster management. We also want a place to track and coordinate cluster-wide operations. If you've ever tried figuring out how long it will take your cluster to finish rebalancing, you know what I'm talking about. And also there's a lot of stats that are being tracked by the Ceph monitors that really have no place in the very, very performance and operationally critical models. So, looking at where we go, if you look at Kraken, Ceph Manager is already in, which is a new daemon that is running currently on the Mons. I will get into that, and that implements a lot of that functionality. So it has a pluggable architecture. It's written in C++, but it also includes C Python, so you can have Python plugins. It's supposed to track long-running cluster-wide operations and jobs. So with the start time, with the start state, so you can figure out the end state and how far along you possibly have to go, progress for scrub and all those things, and take over the non-essential stats from the monitors, like the PG stats, which really have no place there, and being a common management endpoint that all tools can connect to, right? It takes on what used to be the Calamari REST API and embeds that. And the good thing is, it's already there, right? So it's already merged as part of Kraken. For some reason, the interim release get all the cool names to release the Kraken. That should have been the stable one. So it already does some of the functionality. I don't want to bore you with the details here, because I otherwise get thrown into the pool, and I also can't juggle. So some things that it won't do, it will not replace Ansible, Juju, Puppet, Chef, Salt, CF Engine, and all those things. We have Kubernetes for that, right? That will be the next type. It's not a GUI, so it's a common endpoint for interfacing with user interfaces, either graphical or command line interfaces, and it's not a generic UI framework. So the UI is still, product managers still get what they want, right? And it does not replace other critical parts of Ceph. It does not replace the Mons. It does not replace, the common config store that's hopefully coming. That's all new. And so some of the ideas where this could actually help you with, without the technical details, which probably nobody cares for, it will allow you to aggregate information from multiple sources and get a common answer from the cluster. So right now, every OSP knows a little bit about what's going on in the cluster. It's not really aggregated anywhere. So if you want to figure out who's your most busy client, who's your most busy RDD image, you currently have no way. Or even just figuring out RDDDF, how much disk space your RDD image actually allocates is a long-running operation in Ceph, and tracking that would be really useful. Or something like the progress bar, which is so 80s, right? But a progress bar on backfill or backrooming the node would be really cool. And that once we have that job framework, we can just generalize that and use it in other places. Or jobs, right? Not just progress, but doing gradual wake up for PG-num. So you can go and set the target state, and the cluster will increase it in small increments instead of you having to give small incremental commands, right? Waking up new OSPs or even weighting them down based on smart data that suggests that your SSD is bearing out and pulling them out from the cluster. So all of that is coming. Yeah, right. Who cares for this? Obviously, everyone who's writing a new graphical user interface. So right now, none of the user interfaces use it, right? But Tendril, I'm told, will hopefully. OpenStack definitely will, which is sort of like what product managers here have decided, and hopefully everyone else who wants any sort of management framework. And it's supposed to be production grade with Luminous, right? So it's already Kraken. You all should be looking at it if you're writing management front ends and contributing to it and using it as part of Luminous. So I think that's it. So I hope I can avoid the pool, and thank you for being here. If you have any more questions, let me know.
Our next speaker is Javier Pena. And those of you who are not listening to the presentation, please take your conversations to the other side of the pool so that we can hear in here. Thank you. I see that was a very unexpected announcement.
Hello everyone, my name is Ceph and I'm going to give a brief overview of different RDO repos that are available for you to consume. So, raise your hand if you've ever had trouble understanding which RDO record you have to use, where to purchase it. Okay, we've got some people having trouble with that. Actually, it's not that difficult once you get an idea of what it is. So we have just three different kinds of repos. First of them is stable, second of them is testing, third one is track. So I'm going to describe the three of them, where to find them, and how we trigger package builds on each of them. So stable repos are the ones you should use unless you really know what you're doing. They are stored in the CentOS Cloud Seek space. That's the URL. These are digital design, and we use the release project tags as a source for this thing. So, for example, now that we have Newton packages, Newton repositories with proper tags for Neutron, Nova, every other project you can name it, we create a new package based on those tags. There is an exception, and that's if your project is too lazy to release tags, and then we get to the release date for Newton, then we may end up using a Git repo, or a Git commit, specific commit from your project. If you want to avoid that, please release the tag before we have the Newton canvas. So these are the ones we do for production, and the way we create them is actually we create them automatically, and we'll see later how we do that. But these are manually tagged. So we have the packages built in the CentOS Cloud system, and then once we know they're ready to go, we tag them manually, and then they show up in the CentOS CDN. The second type of repos is testing. These repos are also stored in the CentOS Cloud CDN. This is the URL. In this case, these are testing packages. This means that we don't have still full confidence of them. We haven't taken them through full CI, and they are not digital designs. Okay, so this is the main difference. Again, we will usually release these packages from release project tags. So, for example, now that we are in Newton 7 release cycle, for Newton we will have new release and new tags. Once your project releases a new tag for Newton or stable Newton, we will create a new package from it. In this case, these packages are created automatically after we change the spec. So it's important, and they are manually tagged. So every time you release, let's say, Newton whatever .1, we will create a new version of this spec file. This spec file will go to CI. We'll say it works okay, it will finalize that, and then we'll approve it, and then we'll go to build it. We can use it for updates. So let's say you can't wait for stable, you know there's a practice in a specific release version of your package, you can use them to update your packages, that's fine. And you can also test them and let us know if it works fine, we will make them go faster to the library. And finally, for the great ones, we have trunk. As you see, this is a different delivery architecture we have. We're using and we have one URL for each branch. So we have master, we have Newton, we go all the way back to Liberty right now. These packages are not signed, and in this case, we are building the latest commits on Ceph for each different action you have written. There's a little section I'm going to explain later. So this is the latest and greatest, and just vanilla code we have on GitHub. We just package it and make sure it's available. In this case, the creation is automated, which means that we have a machine where every 5 minutes we scan through all the different GitHub repos, fetch the latest content, and once the content we check if there's any new comment, we just do a new package. You can use it for updates if you can wait for testing or stable. So it's like I just merged a patch on Nova and I really need it now because it's breaking my production cloud. Okay, you can go there, fetch it, update your machine, and after some time it will be part of a pack release, so we'll go to testing and then we'll end up in stable. And we also use it for CI jobs. We have the Puppet CI, we have People CI, we have Cola CI. We have different CI jobs that we just need to run with the latest code, and instead of installing console, we install something. Okay, there is an exception for special collections of the master. We can, I think I'm running out of time. Just talk to me later and understand what's getting better. And finally, it's not something that, this is not something that we are working on behind closed curtains. This is all public. All the spec files are public. They are published on the github.com/RDO/packages. You can contribute, you can help us. We will have a very good system on running on review.RDO project on RDO.org. And you're more than welcome to help. There are different branches we use for stable testing. And please help us. We will be very happy to have more contributions. And this is it. I hope you're less confused now. If you're not, I will be taking a glass of wine now that I've finished with the presentation. And I guess I'm asking questions. All right, thank you very much.
All right, once again, we're going to ask everybody, if you're interested in the presentations, welcome to be in here. If you're not, please direct conversations out there. And hopefully, both groups of people will be able to consume both conversation and presentation, as well as the alcohol. So bear with us for a little bit more. If you really want to have your conversations indoors, we'll be down in a few minutes. So help us out. All right, next speaker up, we have a friend of ours from Sandus who's going to tell us a little bit about what's been going on with Blue Story. Alan, the mic is yours.
I feel like I'm going to put some slides tonight, but when I first signed up to do this talk, they were like, no, you don't need slides, you can just talk for a few minutes. Yeah, okay. Now I feel like I'm just the first guy up here doesn't have any slides. But anyway, well, thank you, gentlemen, for Intel. They showed off some of the performance benefits of Blue Story that have come in. And I thought I would just talk about it for a few minutes because that's mostly what I get to do these days. It's the excuse to go visit the world. So I'm glad for the excuse to be here. I'm really enjoying it here. So if you look at Ceph, the Ceph that we have today, backend storage is a file system and if you actually dig through that and you look at it, you realize that this is pretty crazy implementation. You get right down to it. It's got a lot of problems. It's pretty well on hard drives, but it's like a lot of software, which is when you first get started, you use the off-the-shelf piece of software that's available and feed it into submission to get what you want. And then eventually you come around and realize, well, it doesn't work really as well as it needs to, so let's throw that piece out and re-engineer this on the work. That's what Blue Store is in the back end of Ceph. You got started, file systems well understood, off the shelf, plug it in, you get going fast. But at the end of the day, the semantics of the file system don't match very well with a strictly consistent data store on a distributed environment. And what it really boils down to is transactions. There are no transactions in the file system. And all of Rados is built on the concept of a transaction across the distributed environment. That's really what it's doing for you. So with Blue Store, Sage basically dumped the entire backend and built an entire new backend that essentially solves the transaction problem by taking all the metadata in the system and sticking it in one place. So if you look at the current environment, you've got XFS, which has got its data, its metadata, and its journal. So the next two, LongDB, which also has its data, its metadata, and its journal. And you get this sort of journal on journal on journal on journal problem. Okay? And that's the fundamental reason why the performance of Ceph is pretty good on reads and really lousy on writes. So Blue Store completely refixed that. All the metadata is put together, stuck in a single key value store, which in the current code base is RocksDB. And Sandus has another implementation that we're also pushing into the open source, which we hope will end up outperforming RocksDB, but that's still a work in progress. When we rethought the back end, there were a couple of other things that have been long felt needs that are being added. So, for example, compression would be built in for BlueStore. Just turn it on. You don't have to do no changes in the application, no changes on the clients, no changes on anything. Just turn it on and you're ready to go. Checksums. Okay. Today, as you scale your data, you pretty quickly realize that the integrity of your data falls off with the size of your cluster because your hardware is doing checking, but only locally. And I can tell you as a vendor, people don't want to spend a lot of extra money for hardware checking. Okay. So by putting the checksums into the software, you basically close that gap. You dial up the checksums to match the scale of your cluster, and now the integrity of the data in Ceph is really world class with BlueStore. So the other thing that how much time I have left? Somebody's going to give me the high sign before you throw me in your pool. I thought, okay, I was going to start a talk, but I didn't. When you look at storage management software like this, really the first thing you have to think about is what does my hardware plan going to look like? You know, it's sort of like, forget about that a minute later. You spend all your time worrying about the metadata. But matching your storage management to the hardware ultimately is what limits your performance. So the current environment where you've got XFS, particularly if you have like rotating store, most of the deployments of Ceph have magnetic or domain data and SSDs from the journal. Pretty quickly realize that not only is the metadata split, but you've got metadata sitting on rotating store when you really want it on flash. So by putting all the metadata together in BlueStore, it's trivial to put the metadata on flash and the data on rotating. That sort of hierarchy is actually important, and I want to thank you again for showing that, because the next generation of technology is going to be NAND for your data store and storage class memory for your metadata. And BlueStore really supports that model for both. You should be able to easily evolve into that environment and deliver the kind of performance that the Intel gentleman showed, but should be world class. Okay. The development of BlueStore is actively underway today. If people have followed the dev list, what you see is that for large objects, you get about twice the write performance of file store today, which is what you would expect because of eliminating the double write in the Ceph journal. And the small object performance, just like most software, in the beginning it was really terrible because the software was really inefficient. But over the last couple of months, you've been watching, the performance of small objects has come way up, and now exceeds file store. So basically, when you get BlueStore and plug that in, you're going to see anywhere from about a 30% to 2x write performance boost, but about the same read performance that you're getting today, which is actually pretty good. And the only downside to that is it can really eat the power. So if you upgrade your node, you have all the data away and rebuild it. Fortunately, Ceph's built-in rebuild capability makes that operationally a little easier. Okay, you can just shoot the OSD, tell them to rebuild itself in BlueStore, you know, sort of one by one. You can migrate back. Anyways, BlueStore is going to be, you know, there was a technology preview in June. That code is ancient. It's not upgradable. Just ignore it. There's the new version of the Kraken, which is rapidly at work. Runs pretty well now, but you know, as they say in software, first half of the work takes 80% of the time. We finish that. The next half of the work will take another 80% of the time. That's what's in front of us. Okay. I don't know when the Kraken release is out, but the brewers in it this year. But the hope is to make it the default release for Luminous, which should be, I'm guessing, sometime next year by the time it hits the wire. You probably don't want to touch it for a few months after that in production. So really by the back half of next year, we're going to have a whole new back end for Ceph, and I think it's going to move the fundamental performance to the world class, and there won't be any apologies for that. I'm sure my time is well up.
Thank you very much. Our next speaker is Julio Vidente. We'll be talking about the interface between RDO and Ceph?
Yeah.
In triple S.
You have any group of mirrors, right? Hey, hello everybody. So, this is a meetup for RDO and Ceph. So I'm trying to put together both the status of RDO with the new release and actually status of support for Ceph and RDO, which is the installer and installation. Get your Ceph deployed together with those. So, there are a few things that I think we don't like that are worth going through from the blog post because I think it's given the audience comes by better way to do it. First thing to say is that with the new release of Triglo, which means with the new release of Triglo, we are going to deploy Ceph Triglo, but it will not Ceph under anywhere. And for those that actually started from a previous release of Triglo and are upgrading from Meetup up to Newton, they also get their Ceph updated from 100 to Triglo. Another important step that we got in the new release was that we finally got the Triglo support for running Ceph into S-Linux. So in Portugal, we were not doing this before. Notably not on the OSDs, now we are. And some more features which are probably fully documented in our Triglo documentation that are there and are probably, again, worth going through, are that probably those of you who tried deploying Ceph with Triglo know that they can customize this maps for nodes. So they can choose which disk to use and which disk to use as a journal and which one to put the data. What less of you know is that we have a mechanism to distribute a specific map for different nodes. So that when you have 10 Ceph storage nodes, if they have heterogeneous disk layout, you can actually distribute from Triglo different disk sets for different nodes. It's what's possible before. And another feature that we added with the new release is that you can now fine-tune BG num and BGB num per tool. We used to do this for all tools, and you only could set these for all of them. Now you can do this on a per tool basis. We still don't have something of all this fully automated, but there's a mechanism to distribute a script that will eventually drain your disk so that if you are reading at the moment of a Ceph cluster on those that were previously used for a different Ceph cluster, you can now clear the disks at the time of the deployment. It seems like surprisingly difficult task like it. And last but not least, probably the most unique feature is that we can actually distribute arbitrary config settings in the Ceph conf file. So that means that for everything which is included supported by Triglo, you have a entry point to set whatever config option you want in any of the sections of the Ceph conf file. We don't really automate any logic around the brush map yet, but there is a mechanism so that people can do this option. So initially the nodes are just the OSDs, just the view on our rec layout. Also interesting is that we continue to support the external Ceph scenario. So for those that are more comfortable managing the Ceph development without and outside of Triglo, we continue to support attaching OpenStack to an existing or pre-existing Ceph cluster. So we install it to your own tools and just attach it. And for those that want to do more experimentation, there are a bunch of features which again are not technical development but are in testing, so you can actually try those with the new release. One is the hybrid configured Ceph, which means running Ceph OSDs on the config nodes. This was possible because with the new release of Dribble, we added the composable roles mechanism, something that allows you to relocate services to different roles. So now we can just move a set pointer microcube via role Yaml. We also added support for run scaling. We didn't have this before, again. So now with the new release, we can choose to deploy random gateway to replace script entirely. You're going to need manual configuration of the component and just get it out running instead of script. And we also got support for Manila with the new release in Dribble, and the Ceph driver for Manila, which again is currently testing and so the main reason why I am spending this 5 minutes is asking for feedback. Please try out all these things. Come back with feedback, thoughts, or whatever you feel is worth out. That's it. Thank you.
All right, thank you. As many of you know, Intel has been involved in the Ceph world for a long time. But one thing that we have done a lot of work with more recently is bringing our story of Ceph and ARM up to a little bit more of a modern standpoint here. So to tell you a little bit about what's going on in the world of Ceph and ARM and OpenStack, is what our friends from Lenaro. So Gemma, take it away.
Thank you. Hi guys. I joined the lab 3 weeks ago. They gave me a bunch of servers, and they told me set up OpenStack. And I said, okay, thank you, Martin, for the task. And I've spent the last 3 months setting up OpenStack, fixing back, working with people, building things around, working with the Ceph community as well, working with RDO, Red Hat people. We have Salena in my team. We have a few ARM engineers. We have one Red Hat person. We have a high silicon person. So it's a diverse team from several companies. And right now we have a cloud that is actually spinning instances. You can do almost everything you can do on an Intel cloud. We have a Ceph backend. It's working great. And we have it on the tools of the ARM board there for you guys to see. So if you want to come and see, ARM board in there, it's going to look exactly the same as Intel. And that's what we've done, really. If you have any questions, just find me and I'll give you all the more details.
All right, thank you.
All right, our next speaker is Jeff Ruzicott. We're talking about our. I get your attention. I did that on purpose. RPM factory workflow with RDO PKG.
So first, I would really like to ask the people who are not interested in the presentation to go down with the volume, please. Because I was standing next to that and I didn't hear a word.
Reach.
Oh no, this doesn't have this output.
You have HDMI?
Yeah.
Yeah, we have HDMI as well. You're up for it.
Yep. So hello, I'm Jakub, I'm packaging, and I have just a pretty short story about how we manage patches in RDO, which changed recently. So before we had these patches branches, so magical branches in Git that contain the patches on top of the upstream version, but the problem of that was we lost the history. So someone introduced the patch to the package, and then we replaced the version, and no one really knew what happened and who introduced the patch and who approved it. So we created our own workflow. Fred was behind that mainly. It's built on the RPM factory, and it lives at review.review.org. I can't really hear myself, and I'm holding the mic. So if
Yeah, you just gotta go with it.
I can't hear myself. Like, I'm not gonna talk under these conditions. So if you could shut up, please. Thanks. Yeah. So as I was trying before, we changed the way we are managing patches in RDO. So now what it means, all the patches are held as open carried reviews. So let me show you. So now if you want to introduce patches to an RDO package, you basically just select the patch you want to pick. Of course, that must be an upstream patch because we don't fork upstream. So you just cherry pick your patch and you do a Git review. You actually do RDO PKG review, which sends the patch to the right URL. But all the patches are now held as reviews, and so you can use RDO. You can use review.rdo project. So the good things now we have only 2 patches. We got lots of downstream patches in previous releases, but now in RDO we only have 2 on Swift and 1 on Ironic. So all this effort will maybe benefit in the future. So you create a patch, and then you can view this patch in the RPM factory, and it's a review as you know it. Only difference is that there is never a class-bound workflow on such patch. This patch stays forever as an open review, and there was lots of code in RDO and other tools to support this workflow. So once the patch gets into RDO, all the information and all the metadata is stored in the Git review. The workflow with RDO PKG for the pictures didn't change, but we have more information now. So let's keep the patches down to the minimum because we don't want like downstream patches. But if you really need to patch RDO packages, there is this blog post on the RDO website which will guide you through. It's called Introducing Patches to RDO Balancing Packages, and that's all. Just for the few of you which actually maintain packages, and that's it.
All right, thank you. I guess the OpenStack community is a little bit more used to fighting for speaker space, so appreciate that. All right, our next speaker here is actually going to branch out from the pure technology, and George is going to talk a little bit about some of the world of cancer research and how Ceph is impacting that world.
All right. Hello everybody, my name is Dr. Castro. I'm a cloud architect with YCR. YCR is the largest cancer project in Canada, one of the top 5 in the world. And it holds the network of ICDC, which is the International Cancer Genome Consortium. And that has the goal of analyzing the cancer data from 500 normal tumor samples for the 50 most common types of cancer. And each country in the project provides data for this project, and we will try to have at least 2 samples from different countries for each type to have better variety. somebody who has liver cancer in Japan has different mutation than somebody who has liver cancer in Germany. Okay? The Cancer Genome Collaboratory project is based on the fund of the Government of Canada. The goal was to create 3,000 cores of compute capacity and 10 to 15 petabytes of object storage to store the data. And basically, we want to allow researchers from all over the world to come to where the data is and have an account, have compute capacity to the analysis there, instead of downloading the data to their clusters, which takes a lot of time, and create a lot of local copies of the data. This is going to improve, hopefully, finding the cure. The genomic workflows are different than regular web workflows. So, SDM are large VMs, 8, 16 cores, a lot of memory, and they need a lot of disk space for the data. And then when they run, they saturate either the CPU or the memory or the disk. So there are different steps in the workflow, depending on what it does. When it saturates, numbers, and other features. For this reason, basically, we don't have line migration, other features that basically are required for enterprise environment. There are ephemeral, you run the workflow, the branches, you know, of the workflows, you can start them on another node. It's a pure cloud design. The workflows, as you can see, have a very good computer to memory ratio. So for one core CPU, you get 8 gigs of RAM, 162 gigs of local disk. The largest one has 5.2 terabytes of local disk, so we have samples that are like 800 terabytes, 800 gigabytes files. So you download that file and then you have to align it to create the same size of file, even larger actually, so you need at least 1.6 terabytes local. Some of these basically the application that we have is high-density compute chassis for compute servers in the 2U chassis, sharing just the power supply. Each of them has access to 6 drives. We also have 8 storage nodes. We use high-density storage node for Ceph, 36 drives, general specific. We got basically all the space in the rack, all the ports of the 10 switch. And the fact that we have CPU on storage in the same rack allows us to keep some of the notebooks in the rack local. So when researchers create volumes, it's not a main use case. They do have access to volumes. They create volumes themselves. They read and write the primary replica. Some of the primary replicas will be on the storage node in the same rack, so the traffic can stay local to the local switch. Also, if we have to put just compute nodes in the 42U rack, that would totally saturate the power feed. So the secret plus the feed generation would be too much. So we have to mix different storage. In the right hand, we get on top, we have 2 1U switches, one for management, one for production and gigs. Then we have 4 compute chassis, that gives us 8 compute chassis, about 600 ports per rack. Then we have 8 storage nodes that gives us about 2.3 petabytes if you go with 8 terabyte drives. Currently, we just have 8 terabyte drives. In the past, we have 4 or 6 terabyte drives. And as the prices go down, we started to buy 8 terabyte drives. The controllers, 3 controllers, we have SSD drives for the controllers because basically they run everything that is required by computer, plus them. But in order to move, we have to dedicate RAID 1 SSD container to Ceph 1 in the operating system. So no contention for the IOS. MariaDB is a MySQL and its own RAID 1 SSD, no problem there, and the third one is for kilometers. If it works with SSL on the people IP that is radio, controllers have 4 interfaces. Okay, because we have little gateway routers, we have Ceph one, we have other gateway instances, so they are the data path of the north-south track. And we use GRE for the also, we can program basically the computer has 6 2 terabyte drives. Okay, they are 7.2K RPM drives. But in the RAID time, this gives us good redundancy and higher performance. And because you only have 3/4 of the VMs per container, they both need to share these 6 drives. And because they not necessarily are in the same step in the process when they have to read and write from the disk, basically it's very possible that one VM has dedicated 6 disks. And if one VM saturates the local disk, this is not going to impact other workflows running on other containers. So smaller scale domains. Step 1 is we have 3 controllers to run anything because one is saturated. So we have 400 instances to different ports, load balanced by each proxy, and we have 4 others to make sense on the transferring nodes in different racks. We did some other gateway tuning. So we have basically the client, application client that does upload and download, because it protects data and has to be, I will also more exactly, right? But we have 64 megabytes track size for other gateway, we have less random objects. Increase the internet for the drive. We have sharded budgets. The second one is 36 drives. We have SSD in the rack as swappable. We have 2 10 bonded and active for the primary for the public network. The other 10 gigs for the verification. Also some graph later on how it works. On the networking side, we have Brocade triple track switch that has 48 10 ports downstream, has 640 gig ports upstream, so the 2:1/3 ratio. And because it's stacking, because all the ports are non-blocking, and it's very expensive to stable, so no need for computers or objects. And basically, we actually use the transceiver to fiber just to link the first rack to the last one because the disk is too large, too long to be accommodated by OpenStack. Software side, run OpenStack started with Juno, and then with Kilo, now we're on Liberty, we started with Giant, now we get to Hammer. We continue for Ansible, Homebrew, playbooks. In Zabbix, I have to mention we have about 30,000 metrics to monitor. Everything we monitor, we keep the data as long as we can. For now, the 200 gigabyte RAM containers for the MySQL that Zabbix runs. We run the infrastructure, but not just for monitoring. With the custom client that we have created, basically we created this client before we started the environment in order to store the data in Amazon, so we use the same client for the SDK in Amazon as well as it's also very interesting like farm slicing. So if the teacher wants just to download data about chromosome 18, okay, so download the entire genome. You can do just that part. So the client knows which multi-part to provide, and that was just that part of the large 250 part. There's a cloud usage in the last 18 months, about 9,000 instances, 5,000 in the last 3 months, 500 terabytes in rather big buckets, 60 in the single volumes, and 2 terabytes in the glass pool. I did a test. I started 40 instances and generated started the download mechanics. So the gigabits per second. And then it started to slow down because the VMs had to write the data on the disk, and that's why actually they were limited by how fast they can write down the data they were getting from Rados. Again, this is the two Rados proxies, load balanced by DNS, and then load balance again against standard gateway instance 0.5 and 7. This is when we had it last week, 3 storage nodes with 8 terabyte drives, so it's 108 drives. As you can see, we did add the drive to the weight with more chance. You can see that it's about 14, 15 gigabits per second in the replication network, which means that if you had that 10 gigs before we saturated, in about 2 days we had 450 terabytes of data from the RAM, from the old racks into the new rack. this is developed from the CPU. Basically, you can see that the old nodes are on top. They are very little CPU. They are testing replicas. The new nodes have about 50% CPU utilization, but the white line is done spending IO weight. So even if you get them more CPU or more cores, it doesn't have that. They were basically waiting for the to accomplish the request. So it says that this packet CPUs look at exactly what is being used in the CPU. It's just user time or with the memory, it became interesting because during the rebalancing, the old nodes and the new nodes, they didn't show any kind of memory contention. It's hard to have this big RAM because it's in the cache reads, but in terms of rebalancing, it's not really a requirement. Because this from the old nodes as they were being drained, and the new nodes as they went up. You see a spike up on the old nodes because they also formed the replica basically during development before the savings was totally removed. So they could have had basically on the old nodes as well. I was having mentioned on the new drives, and I would like to thank the planning agency for running my project.
Thank you. Our next presentation is Alfredo Raleigh. He'll be talking about CI and RDO with multi-year testing. For the last RDO one that was here.
Okay. Hello, my name is Alfredo. I work for the RDO community project, and I'm going to give you some highlights about how we do testing in RDO project. Okay. If we think in what we do in RDO from a high-level perspective, I would say that this is the very core workflow for RDO. We create packages, we test, and we publish those packages to be consumed by users. So for us, testing the content we provide is part of the core of what RDO does. So you as users can run reliable OpenStack services using RDO. Okay. So around this workflow, we execute some different kind of tests since the very beginning until the end. So while we create those packages, we run the unit test for the upstream unit test for the software we are packaging. So that allows us, while testing, to check that this software runs exactly the same when using our provided dependencies that are created as part of the project as they run in the upstream case. Okay, so this ensures we are doing requirements, we are doing all requirements fine as part of the process. Okay, this is kind of very basic unit test. It's not a big deal, but yeah, provides us kind of trust on what we are building. In case this unit test is done fast because we are not providing the right dependencies or whatever issue, we will get a file to be from easy that someone in the world from the RDO community will take care as soon as possible. This is for us one of the priorities to avoid any file to be from store. So you can be sure that if you need the space in RDO, that will be fixed soon. This is well packaging, but probably the fun or the more complex part, what the test we do is after packaging. So once we have created all packages, we have publishing the very basic repos that Javier has played before. We want to ensure that those packages runs out of the dev stack installer that runs on the upstream gates. Okay. So to do that, we want to ensure that the content we provide through the RDO repos can be properly deployed using the supported deployment tools, OpenStack, Puppet, or 3PO. Okay, and all the tests, all the integration tests pass with those configurations out of the stack. Okay. To do that, we have what we call in RDO the promotion pipelines, which are a set of pipelines or jobs running in Jenkins in the central CI infrastructure, where we test not everyone, but some content, some repositories, and we test them in different scenarios. Okay, we deploy them with Retail, okay, in two different scenarios, one with PageMaker running and without PageMaker. We deploy it with OpenStack also, and we deploy with Puppet directly using the upstream Puppet OpenStack integration test. Okay, we do this based on some projects that are publicly accessible and anyone can use. For example, if we use Word or I don't know if this is around, but Word was created by David, so that allows us to run Puppet and PuppetStack jobs similarly as done in the application for those projects. We use Twitter Bitstar that is used also for upstream. So we ensure that we are using those records, those RDO records, in 8 different scenarios for each one of the versions of the releases we run. We have some pipelines used for every version for DeLorean repos, okay, for master, for Newton, for Mitaka now. And we have some other repos, some other pipelines that we use for stable repos, okay, for those repos that have been pushed to buildbox. So if they pass, they will be promoted to the official record, to the official stable record, okay. For the case of particular case of the true repos, for those versions, for those version exact snapshot that pass all these tests, we apply a symlink, which we call current pass CI, okay, that is something that is like we put a stamp there that, okay, this repo has passed all the scenarios and run successfully, okay? And we have another two promotion pipelines that are specific to different tools. We have one that only is running 3PO and another one that is running Puppet, okay? Another aspect of testing in RDO is the testing of the tooling that we use ourselves to build those packages. Okay, we apply the same gating CI principles that are used in OpenStack. Okay, so we use CI jobs to test every change on the DeLorean, on RDO info, on every artifact that we use for testing. We apply CI gating CI. Okay, running using software factories. Okay. We are working even in improving this. We are testing while packaging, we are testing after packaging, but we are testing a before packaging, which means running as soon as a new review is in upstream, is being tested upstream. We'd like to be able to test that review, as it's merged, it will be properly packaged. Okay? Running CI, third-party CIs from our CI. Okay. And just to finish, if you are interested in the status of our CI on every moment, we have a publicly accessible dashboard where we have, with a nice color, green colors, the status of when was the last time that every promotion pipeline passed for each version. Okay? That's it. If you are interested in any more details, you can come ask me, and I will point you to the person that really knows. Okay? Thank you.
All right, thank you, Alfredo. We are down to our last two here. The first of which will be one of our friends from CERN. Dan Vanderster is going to talk about how you replace several petabytes worth of Ceph with no downtime or no interruptions. So let me get set up here and we'll go off the races. HDMI or DVI? Or your
Thank you, Patrick. Okay, I'm just going to go with it. It's obviously showing the presenter view here and the presentation view here. That's okay. This talk is called How to Replace Several Petabytes of Ceph hardware without downtime and how to keep the OSDs balanced. If you ever have to do such a thing in the future and you're not listening, then I give you. So this was a slide that I showed a few months ago now at Ceph-based Facility, which was that to pose the problem. We have around 1,000 OSDs to replace one for one with larger drives. We have to upgrade our cluster from a 3 petabyte cluster to a 6 petabyte cluster. And we knew already how not to do it, which is just to add 1,000 new OSDs and then remove 1,000 old OSDs. That's not how you do it. But we weren't sure how quickly we should be, putting the new machines into production. OSD by OSD, server by server, rack by rack. Should we tweak whole waves of racks at once or by this? We didn't know. And the other considerations about that was to save the OSD IDs because of some technical reasons. And we also didn't want to have to babysit this day by day because we knew it took many months. Now, I can say that this campaign is finished. We did it. There was no downtime. And now I want to explain how we did it. The procedure that we followed was to add one new rack, which represented about 10% of the hardware in the cluster. And we created OSDs by setting their initial weight to 0 and setting the crush update weight on start to true, which means that they get created in the cluster with 0 initial weight. So you start these demons, they get 0 data. Then we would also be draining old racks very slowly and being sure to set OSD crush update on start equals false. Because if it would happen that a machine would restart during the draining procedure, it would be re-injected to the cluster with its full weight, which is not very good. And we repeated this again and again. Okay, but we actually wrote a tool for this called Ceph Gentle Reweight. And this is what you should be paying attention to. What does Ceph Gentle Reweight do? Well, we give it some arguments. The OSDs to reweight, the maximum number of backfills that you will tolerate in your cluster, the maximum 4 kilobyte write latency, which I think is important, the delta weight that you want to incrementally change the weight of the OSDs, either up one bit at a time or down one bit at a time, and the target weight that you want to get to, which is either the full capacity of the drive in case you're adding machines, or 0 in case you're draining machines. And yes, there's the flowchart that explains how it works. And this is a plot that shows the capacity gently going up, waiting flat while we wait to do something, probably a weekend, and then draining another rack, and then increasing again, flat, draining, adding. So we added and removed capacity over a period of around 3 weeks to a month. And here's proof that this was working. This script I had set to keep 50 to 60 PHPs backfilling flat throughout the entire intervention. And this is our monitoring showing 50 PGs in the backfilling state. It's also interesting to note the way that this is done, the objects stay in the misplaced state, not in the degraded state. So at no time during this intervention was there any object with less than 3 replicas. So this is a safe intervention. They're just in the wrong OSD. So 50 PGs in our cluster happen to map to around 3 million objects. And this is the activity during the replacement campaign. So throughout this campaign, we still have roughly 15,000 IOPS in the cluster, around up to a gigabyte per second of I/O, and the latency which we measure every 1 minute was still under 10 milliseconds per write and still under 5 milliseconds per read. So this was totally transparent. And this is the whole reason I gave this plot, this talk, is to show this plot, because I discovered that Grafana has a most deviant function, and with that you can just quickly give it a list of all your OSD space utilization, and it will spit out this, which I think is really beautiful. It shows OSDs being drained and new OSDs being filled. And then at the end, they have a kind of spread between 20 to 45% space utilization, which brings me to the second part of my talk, which is how to balance the data. Now, balancing data in a Ceph cluster is a challenge. So I'll skip this slide, except to say that Joule has a new feature to reweight the usage, the reweight an OSD by its utilization. However, it turns out that this function in Joule and later gamma releases has some limitations. If you have a non-trivial crush tree, it simply doesn't work. And so an example of this is if you would have a 3-node Ceph cluster, and one of those nodes has smaller capacity than the other two, then crush reweight or Ceph reweight by utilization will, over time, drop the weight on the smaller node to 0, 0, 0, to eventually 0, because its utilization is higher than the others by design. Okay? So I've always maintained a Python port of reweight by utilization, which I call crush reweight by utilization. It's actually should be called Ceph reweight by utilization, anyway. And to get around this limitation, I added a feature which is called ---- bucket. So this is not a S3 bucket, but this is a crush bucket. With this tool, you can reweight just one bucket in the crush tree. With that feature, now we're finally in a situation where we can run a cron every hour or every 2 hours in this case, where if the health is okay, we will reweight the utilization of the cluster. So this is a similar plot to the last one, showing that we squeeze the OSD utilizations down. So the top plot is the top 20 utilizations. We squeeze it down so that they're now very close. And one more thing, I've been asked many times, how do I generate the nice plots of the PG utilization? And I always use this there's a nice Python tool called histogram, but I decided to build it in with some Ceph knowledge. And now in the certain Ceph you have this nice tool called Ceph PG histogram that gives you a horizontal histogram of the number of OSDs and the number of OSDs that have a certain number of PGs. This is run on a cluster that by design has basically a binodal distribution. That's it. So this talk basically introduced a few new tools: Ceph gentle reweight, crush reweight by utilization ---- bucket feature, which uses a new Python logic of Ceph OSDs in bucket. Okay. In there, hidden, maybe you notice, there's a tool called Ceph leader, which is just a very trivial bash script that we can use so that on all of our mons, we can run cron job, but only the leader of the cluster is going to run the job. Very useful tool. And Ceph PG histogram, which is also kind of useful. We will try to contribute this functionality upstream, probably in Ceph and RDO, which is what's in the language I understand. That's all. You have the answer. All right, thank you.